Okay, before I take the second example, please check these ones out. Obtain the additive inverse of A plus 7, B minus 9, C x, D minus y, E 2C over 3. You just heard me a short while ago speak about additive inverse. Use these ones to test out if you truly understood. If you did not understand me, please get back to it again to understand additive inverse. If you do, you come back to answer these questions. Now let's move on. Now, another example in which the only obstacle is that the coefficient of x is not 1. It is 3x is equal to 12. Let's see how to go about it. Now this is number 2. That is example number 2. Don't forget that in the first example, we learned how to make an adder become 0. It was minus 5 we used to make the adder become 0. So it is as if we have used that example to learn how to make adder 0 in all other cases where the adder is not 0. Now we face this example, number B. It says 3x is equal to 12. It means that there exists a number, we don't know it, but all we know is that 3 times that number is equal to 12. Again, you could be tempted to start using trial and error or intelligent guess to get the correct answer. By now, you could have gotten 4 as the answer. You are not wrong. Yes, the answer is that x is equal to 4. We know. But you should not rely on that method of guessing. Time is coming when you will no longer be able to get the correct answer just by guessing. Let's see how to use logic and other principles of mathematics to solve this equation. 3x is equal to 12. Now, don't forget that solving an equation means clearing all obstacles that prevent the unknown from possessing all the basic characters it should possess. In 3x is equal to 12. The only obstacle is that the coefficient of x is equal to 3. The only obstacle is that the coefficient of x is 3 instead of 1. So we should know that every other property or quality of a clearly expressed solution is with this x, except that it has 3 as its coefficient. That means that that 3 is taking the place of 1. Solving that equation simply means that that 3 should be treated to become 1 because 1 is in that position where 3 is occupying. Now what do we do? How do we convert that 3 to 1? Of many ways to convert a number to 1. The one we apply in solving equation is when a number divides itself, the result is equal to 1. Or when a number multiplies its multiplicative inverse, the answer is equal to 1. These two statements are pointing to one thing. First, look at this one here. It says 3x over 3. By associative law, we know that this 3 is free to divide this 3. By associative law, we know that this 3 is free to divide this 3 to give us this 1 here. And because this 3, when it divides the 3, would change the value of left-hand side to make it become 1x, the same division must be carried out on the right-hand side. That is why on the right-hand side we have 12 over 3. It means that the new operation here going on the left-hand side is division of the 3x by 3. Since that division is a new operation and it changes the value of left-hand side, we should carry out division by the same 3 on the right-hand side. That is why we say here that both sides divided by 3. What about being multiplied by multiplicative inverse? Recall, I said earlier that a multiplicative inverse is a number which multiplies a number to yield 1 as the result. If you have 3 and you want to make 3 become 1, you have two options. It is either you divide 3 by 3 to give us 1, or we say 3 times 1 over 3. 3 means 3 over 1. Then, what multiplies 3 over 1 to give us 1 over 3? It is its reciprocal. When a number is turned upside down, we call it reciprocal. Even if that number appears not to be written as a fraction, we can use 1 to make it appear as a fraction. And if we're looking for its reciprocal, all we do is invert it. Let that number on top be below, and let that below be on top. So multiplicative inverse of a number equals its reciprocal. Therefore, the multiplicative inverse of 3 is equal to 1 over 3. Therefore, the multiplicative inverse of 3 is 1 over 3. Therefore, to convert 3 to 1, we either say 3 divided by 3, or we say 3 over 1 times 1 over 3. Either way, the answer will be equal to 1. Now, whether we multiply this 3 by 1 over 3 or we divide it by 3, the answer is equal to 1. And the same thing was done to the right-hand side. So both sides simplified, we have 1x is equal to 4. This 1 is here to highlight the importance of the fact that 3 that used to be here has become 1. But we remember that whenever 1 multiplies a number, the result is that number. That is why 1x has become this x. This we have seen earlier. If we simplify right hand side, we still have 4. Therefore, the x here is equal to 4. And in that case, solution has been expressed. Solution to that question, 3x is equal to 12. So with this number B example, we have learned how to make coefficients become 1. Please watch out. Now check these questions out. Number 1 says, obtain the multiplicative inverse. That is the reciprocal of A, 7. Don't forget that 7 means 7 over 1. That will help you when you want to invert it. Then B, 1 over 12. C, x over y. D, 0.5. Please don't forget to change that 0.5 to vulgar fraction before inverting it to get its inverse. The number 2 question says, by making coefficients become 1, solve A, 9x is equal to 36, B, 4y is equal to 20, C, 12c is equal to 144.